All right, the central limit theorem is basically a modification in your z-score that includes that right there. All right? The only difference in 6.3 and 6.5 is a modification in the z-score. Right there. So in other words, your z-score is in 6.2 and 6.3. If you have to use your z-score in 6.2, it's equal to x minus x bar over standard deviation. Everybody with me? Okay, now the difference is in 6.5, you're going to be saying, okay, blah, 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 find the mean and standard deviation, blah, 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 or find the, not the mean and standard deviation, find the probability of, less than 49 or whatever. And then it's going to say B. And then it's going to say, what is the probability of all 49? It's going to give you that little bit of that B information. And when it gives you that, you're going to be dealing with this z-score formula. Okay? That's the only difference. So this is 6.2, 6.3. This is 6.5. Do you do everything else the same? Yes. Okay? That's usually why I don't do 6.4, because 6.4 kind of throws a monkey wrench in it because it kind of gets you off the path of the z-score. And it's just a lot of skewed right and skewed left, and we should already know what skewed right and skewed left is. And it's estimators, and we're not dealing with estimators when we're dealing with probability in the curve. So I just skipped 6.4. All right? So write down this formula because that is the only difference. Now what they'll do is they'll set the question will set you up. .3. Okay? It's going to set you up this. And then it's going to give, that's going to be like A. And then B is going to be what if, or what if, blah, blah, blah. And then that's going to be this guy right here. So let's take a look at what we're talking about. Because this is the best time to just show you a problem instead of anything else. And there are not many problems because you already know how to do it. All you're doing is changing the formula. That's 6.4, Hubert. Wrong section. Sorry. All right, now I want you to write the question down. And the first thing I want you to do is I want you to designate what is 6.3 and what is 6.5. Assume that a women's height are normally distributed with a mean of 62 and a standard deviation of 2. When you see those two numbers, what's the first thing you think of? Draw the curve. So draw the curve, that's 6.2, 6.3. Then, if one woman is randomly selected, find the probability that her height is less than 63 inches. What section is that? 6.3. Because it's finding less than. Remember, less than is the left-hand side. Greater than is the right-hand side. And what is the right-hand side? 1 minus the left-hand side if you're using the table. So what is 6.5? B. That's 6.5. So, let's take our handy dandy highlighter. Did I hit? Take our handy dandy highlighter and we're going to highlight in yellow 6.2 and 6.3 material. There it is. And we're going to do that right in here. 6.2 or 6.3. And we go, okay, we draw a curve. I'm just going to use, on the curve, I'm just going to use whole numbers. So 62, and then 2, that'd be 64 and 66, and 60 and 58. Now, of course, yours would be in decimals, but I'm just doing that just so I could draw a picture. If one woman is randomly selected, find the probability that her height is less than 63 inches. So I take my blue marker. 63 is right in here. So I'm going to find that probability. So first of all, we got to change 63 into a what? Z-score, Hubert. That's right, class. 62 point, what is it? 62.3 over 2.2. So the Z-score at 63 is equal to, somebody crank this out for me. Well, 63 minus 62.3 is 0.7, right? Over 2.2. Well, 0.7, 70 cents divided by 2 is 35 cents. So it's going to be less than 35 cents. 0.33 something. What does it come out to be? 318 or 32? So there's your Z-score. That's your Z-score at 0.32. Now, let's check our common sense. This point right here is 0, right? This is 1, this is 2, this is -1, this is -2. So, are we between 0 and 1 with our Z-score? Yes. Okay. Now, what table are you going to look at? You're going to look at table A2. And what table? The positive what? Positive Z-score table. Or if you don't want to use the table, you use your handy dandy calculator. And what do we type in? Second, bars. Help me out. Is it normal PDF or CDF? I can't remember. Huh? Normal CDF. And then they want to find the left-hand side, so that's going to be negative 99999, which is infinity, negative infinity. So negative 0.99999, and I usually carry 4, 3. Do not carry 2 because that'll see a difference in your probability 3 digits. So don't use 0.99. Use 0.999 or 900. I'm sorry, not 999. Sorry. That's negative infinity. 2 what? 0.32. And enter. And somebody tell me what you get. Well, common sense. What are we going to be at least over? 50%, because that's half the tank right here. So we're probably talking about half of 34. I think that's 34. Half of 32 is what? 16. So we're probably talking about 56%, somewhere in there. Not 0.32, because that's not even 0.5. So that's a third A third of 33 is 11. So 11, I'd say 61% is what I say close. What do y'all get? I'm sorry, what? It's a miracle. 0.625, which is 62 point what? 5% chance, or a 0.625 probability. Now that is all of this right here. That's 6.2 slash 6.3. That's what you already know how to do, because one, I taught a couple of days on it, and then two, I put 5,000 or 6,000 videos on YouTube that one person probably saw. Okay? So no problem there. The 6.5 part is right there. And I'm just going to go to the next page, and I'm going to do it in green. Yeah, just come on in whenever you want to. All right, so this says if 34 women are randomly selected, find the probability that they have a mean height less than 63. If what? If 34. 34 women are selected. You don't want a piece of watermelon? You don't want my candy? My candy not good enough for y'all? No interaction, nobody eats candy. Y'all weird. All right, now, y'all won't even spend yourselves. Mr. Bright, you're weird. Whatever you say. All right, X sub 34. So let's talk about this a minute. I'm just going to draw my picture again. I'm going to do it in green since this is the 6.5 part. Assume that women's heights are normally distributed with a mean of 62, 64, 66, 60, and 58. And then the first question they said, how do you know if one person is selected? So like you put, they don't give you any kind of numbers. They just say, you know, it could be 500, it could be 5,000. So they take each woman's name and they put their height on it, and then they put it in a hat. And in 6.2 and 6.3, they ask you, what is the probability of pulling a name out of that hat and it being less than 63 inches? And that's what we found and that came out to be 62.5%. So I would bet on that money, because that's almost 63% that you're going to pull a woman's name out that is less than 63 inches. Okay? That's that part. This says, what's the probability of 34 being selected? Now, is that probability going to go up or down? It's going to go down. Why? You talking, I mean, it doesn't say how many, but you could be talking about 500 people. And 34 you pick out are going to be less than 63 inches. There's going to be some 8-foot people in there, or some 7-foot people in there, or some 6-foot people in there, whatever 63 inches is. I don't know what it is. What is 63 inches? That's what I'm asking. What is it, Mr. Bright? You got a calculator, haven't you? Not play football. How much? Okay. All right. So, how many women are 6 foot? There's some that are 6 foot. There's some that are 5'8". There's some that are 5'7". You think you're gonna pick out every person that's gonna be less than what? How would you say? 5.3 or 5.3. You think you're gonna pull out? It's gonna go down, because the probability of picking out simultaneously 34 people less than 5.3, that's going to be hard. I don't know. It all depends on how many people, does it say. But you know you at least got at least how many? 34. So let's do the math. So we got to find our z-score. It should be z, not x. At 34. So x is 63 minus 62. I'm sorry, 62.2 or 62.3. 62.3 divided by 2.2 divided by square root 34. What is square root 34? Is 5.8. Right? Yes, Hubert. Because we're using our head. But go ahead and use your calculator. What's the square root of 34? 5.8. What's this 6 cent for? Z 34 is equal to, I bet I do this in my head too, 0.7 divided by 22 divided by, and I said that was 5.8. Now just for giggles, this is 22 over 6, which is 11 over 3. 11 over 3, right? That's what I'm trying to get some kind of hold on it. 11 over 3 is, yes sir?
This might sound kind of stupid, but how did you get exactly 5.8 from the top of your head? Did you just go between 25 and 36?
Mm-hmm. Well, what's square root of 36?
Oh, 6.
So square root of 34 is a couple of notches down below that.
Right, so you just went.
After a while, you get to know how to do it.
Right. Okay.
That's how.
Then you go like this.
Mm-hmm. All right. So 11 over 6, I mean, what did I say, 11 over 3? What is that, 3 and 2/3, which is 3.67? So 0.7 over 3.7. 34 will go into 70 twice, or 35 will go into 70 twice. So it's going to be around, let's see, I'm trying to do this in my head, so just give me a minute, okay? 37, that's 1, and I have to move 1 over, no, 0.02, or, I don't know, 0.002 should be, what does it come out to be? How much? Do the actual stuff. Do 0.7 divided by 22 divided by 5.8. What do you get? I might have my decimal off. 0.19. Okay, so that's 0.2. I have said 0.02. 0.2. So now our new z-score is what? 0.2. Now let's do our handy-dandy calculator from negative infinity to 0.2. So, second bars, normal, CDF or PDF? CDF. And I'm going to use negative 99999, comma, 0.2. Well, let's think about that a minute. We know that this is around 50%, right? 0.2, might as well say, that's 2, let's see, 2, that's going to be a fifth, right? A fifth. So 35 divided by 34, let's see, 35 divided by 5 is what, 7? So we're probably talking about 57. I'm thinking maybe 57%. What'd y'all come out with? 0.58. Well, some of y'all may think I'm being conceited. I'm not being conceited. What I'm trying to tell you is, a lot of times, you can do math where? In your head. If you were taught how to do math. But if you were taught how to use and depend on the calculator, then you have no earthly idea what I'm talking about right now when I did those numbers. And you're the people that go, what's this 6 cent for? All right? Now, let's see, what was my prediction? My prediction was that my probability was going to what? Oh yeah, just get mad and leave. Okay? What was my prediction? That the probability was going to what? Smaller. Is it? Yes, 58% instead of 62.5. Let's do a nerd. I'm going to let y'all do it because I want you to feel, you know, discouraged. That ought to make me a success coach. No, they should.
She told me her whole life story in that meeting.
Who was it? What's her name?
Coach Christina.
She is a good one. You better hold on to her because she can open doors for you where other people will close doors. She's a good one. Did you tell her you had me for math?
I don't know, I guess she saw it.
You should have. Well, first she didn't say something. Oh well.
Well, she was telling me because
She
my
hates me, I
brother
guess.
and her daughter are like best friends.
Mm-hmm.
So she wanted to tell me all about that.
Well, she likes to talk.
Yeah.
Like, not talk jib jab. I'm talking the ears off a dead goat. I mean, that kind of talk. You ever have a relative like that? It won't shut up. Well, she's a good one. All right, y'all do this one. If you can't, just consider yourself a loser. And maybe quitting school, dropping out, you know. The overhead reach distances of adult females are blah, blah, blah. 197 and standard deviation of 7.8. Well, if you're from America, you have no earthly idea what that means because you don't know the metric system. So anyway, we'll just do it like we're supposed to. 197 centimeters. That's 197 fingernails, width of your fingernails. So, and a standard deviation of 8 centimeters, which is 8 fingernails. Not like that. No yawning in class. Find the probability that the individual distance is greater than 210. What is that? Is that 6.3, 6.5? 6.3, Hubert. That's right, class. You suck. Find the probability that the mean for 25 is greater than 196. What is that? 6.3, 6.5? 6.5. And then C. Why can the normal distribution be used in part B even though the sample size does not exceed 30? We'll get to that. Don't worry about that. Just do A and B.
Priority 1 message coming in on secured channel. freeze it right quick, Vanna, so I can get the roll.
Thanks.
This is so frustrating. You can't even pull attendance up. You have to go to Google to pull attendance up because it won't work on Firefox. But they tell you to use Firefox in the office. It's a conspiracy. It's all Bush's fault. When people gonna realize that? It's gonna let me, okay, good, it's gonna let me take the roll. That's good. Today is the 7th, right? Okay, Remy's here, Bright's here, Brock is here, Cowart's here, Dyer's here, Jones is here, Joshi is here, Long is here, Oyano's here, Putnam, haven't seen Miss Putnam. Richardson is here, and Slinger is here. Is Miss Jones here? I thought so. You're so loud. I thought I saw you. I said yes, but then I corrected myself. Okay. All right, that's done. Okay, pull it back up. Wait a minute, now let me find it. There's my problem. There it is. All right. Now, this test should be very easy for y'all because you're doing the same thing over and over and over. Okay, A, you're going to use 6.3. You're going to draw a picture. And I'm going to use whole numbers. 198 and 8 is 206. And 8 is 214.
and 198 is 192, or 190, 190. And 190 minus 8 is 182. That's 90, that's not 80, that's 80. All right, and they want to know what is the chances, find the probability that individual distance is what? And that's the RHS, which is what? The right-hand side. So, 210. Here's my 210. And they want to know what that average is right there. Now, common sense-wise, we know that this is 50, that's 84%. So we're probably talking, this is 85% maybe, 85, 86% this way. So what does that make this? About 14%. That's right, class. So we're talking common sense, somewhere around 14%. Now that's very, very, very vague. But if you come up with 87%, you know what? That you're wrong. Unless you're looking for the left-hand side. So, we got to change 210 into a Z. So, Z at 210 is equal to 210 minus 197.5 over 7.8. And we know that 2.5 would be 200. So, that'd be 12.5. No, I'm sorry. I was right, 12.5? 12.5 over 7.8, which is 13 over 8, which would be 1 point, I don't know what, 8, 9, 10, so 5 eighths, 5 eighths, 4 eighths, so around 1.5. What did y'all come up with? 1.6? Okay. 1.6. So you go to your handy dandy calculator and do normal CDF of 999 negative to 1.6. And somebody tell me what you get. And that's the left-hand side. What? Point. Okay, you did the right-hand side, I think.
0.94.
Point what? Okay, the left-hand side, and I'm doing this for those people that look up the table, is point what? 9450. 9452. Okay, help me out if you tell me the right numbers. Okay, 9452. Now, if you look in the table, you're going to be somewhere around 9452, but that's the left-hand side. And the right-hand side is equal to what? The complement of the left-hand side, which is 1 minus the left-hand side. So $1 minus 94 cents is around 6 cents. So 0.0548. Is that what y'all get? So about 6%. Mine was off. Okay? So is that what y'all got when y'all did 1.6 to, you can do the right hand side, 1.6 to 9999, what'd you get? That's the left hand side. And this is the right hand side. But if you do it in the table, you can't do that. So somebody do 1.6 to 9999 and tell me if you get 0.0548. Ms. Swinger, what'd you get? Didn't you get that a while ago? Okay. Okay. Now, you have a question?
I was going to ask if you could do the inverse of that. Right?
Yeah. Yep. The reason I did it here is because I wanted to show people at home if they did the table, they would get a number like this. And that is not the correct answer. you have to do the right-hand side to get this. You have to subtract it from 1 to get this in here. All right, so that's 6.3 material. So that's A, 6.3. It says round to 4 decimal places, 0.0548, and they give you a tolerance, a good bit of tolerance on this. I showed you in the last class that we met, 0.0548. I'm going to put 0.0625 because I want to show you what they give you. Now, for those that wasn't here that day, when they program the answers in, they're giving you this right here is that is the calculated on the calculator, 0.0548, and this is what you get if you use the table. So they're compensating when they program the answers in, not you putting the answers in, but when MyLab Plus, when they punch and program the answers in, they're not only taking into account some of you may be using the table, but they're taking into account some of you using the calculator. So there's a calculated answer, and there is the table answer. Then they're giving you a variance of 100 thousandths. So this could be 0.0545, 0.0546, or 0.054 what? 4. This could be 0.0548, 0.0549, or 0.0547. So there's 6 possible answers that you could come up with here. Not by calculating, but in other words, they're giving you a large area. If you type in 1.6, and chances are you're going to get it wrong. But there's a variance in there for you. All right, now B. Everything's the same. X, it says, find the probability that the mean for 25. Now 25, now let me make a note here. 25 is less than 30. And that's kind of the magic number for, if you read the section in 6.5, 30 is the magic number for whether you can use the standard deviation over the square root of n. But it either has to be what? It has to be normally distributed, or n has to be greater than what? 30. So you might want to write that down. It's in the 6.5 reading. All right? So n has to be greater than 30, or normally what? Distributed. So this one is less than 30, but what trumps that? Normally distributed. Now that normally distributed had not been there, you'd have to put in B cannot be done. Because 25 is less than 30. 30 is kind of the magic number in this problem. Okay? So I just wanted to throw that in there because that's what C is about. So
Why is 30?
well, I'll show you. Hold on a minute. Go back to the reading. And, right here. I told y'all to write it down. For all samples of the same size of n, with n greater than 30. Now, why is it greater than 30? I don't know. You have to look up more of the central limit theorem. I don't know why it's 30. I guess it's based on 100, and 30 would be a third of 100. In other words, a third of it. So anything less than 30 would be kind of not really doable because it's less than a third or 30%. It's the only thing I can come up with. I've just always brought that up. Again, it's got to be greater than 30, or it's got to be what? Normally distributed. Okay?
So, B. Um, 96, 196, so. So we've got 197, 198, and 192, or 190, 190, and 182, and 206, and 214. And they want to know, find the probability that the mean for 25 randomly selected is greater than 196. The 196 would be right in here. So that's going to be X or Z at 196 is equal to X minus X bar over standard deviation divided by 5, which is the square root of what? 25. Y'all might need to check that in your calculator. All right, so Z sub 196 is equal to 197.5, let's see, be 196 minus 197.5 divided by 7.8 divided by 5. I'm just going to do a little bit of head calculation here. So we know you've got $1.96 or $196. You owe $197. So you still owe $1.50, right? So it's negative 1.5 divided by, this is 8 divided by 4. That's pretty much 8 divided by 4, which is 0.5. So how many 50 cents are in $1.50? 3. Is that about right? Negative 0.3. Somebody check me. Should be negative 3, should it? I've got a decimal off somewhere. Somebody check me. I don't think it's supposed to be 0.3. I mean, it's not supposed to be 3. I did do everything right up there. Greater than 196. That's 196 right here. It's 196 minus, but that's not 0.3. Somebody do the calculation. What do you get?
8 divided by 5 is 1.56.
What?
It's 1.56.
This?
Yeah.
Oh, I'm sorry. Yeah, I knew something was wrong. How did I know something was wrong? How did I know? Somebody tell me. Because where's my point right here? Negative what, would you say? This is negative 1, so this is supposed to be negative a third. I knew something was wrong because that's way over down here. So that's why you got to draw yourself a picture. Of course, I know there's somebody in here not drawing pictures because they don't have to. And you got to watch your 8 divided by 4 is 2. Okay? I was thinking of 1/2. And then this is 0.75. What'd y'all come out with? Negative 0.75 or what? Somebody tell me. I come out with just using my head, negative 0.75. What'd y'all come out with? When you do 7.8 divided by 5, what'd you get? Okay. Didn't mean to lock y'all down with such high mathematics. What?
That's the 7.8 divided by 5.
Yeah, and do this. Okay, 0.96? Okay, I was off. Alright, so it's not 0.75, it's 0.96. 96 what? 1.5. Well, we only need a z-score, so 0.96 is all you need. I don't know where I messed up on that. Oh, I know. I'm dividing by 2 instead of 1.1 point hold on, 1.6. So that's where I messed up. I just rounded. 1.6. All right, so I get 0.96. Negative 0.96 is right here. So somebody take your handy dandy calculator out, and what do they want? They say it's greater than 196. So we got to do negative 0.96 to 99999. .8314. Everybody agree with that? 0.8314. So what is the chances of 25 being greater than 196? You're talking about an 83% chance, or a 0.8314 probability. 0.8314. And we feel good about ourselves. Yes, sir.
The N30 thing is apparently has something to do with population and how it's shown on the graph. Regardless of whether it's exponential, uniform, U-shaped, or normal population, at N30 it all looks the same.
It's basically a third out of 100, basically.
Right.
That's where it comes from. Yeah. Choose the correct answer below. The normal distribution can be used because the original population has a normal distribution. I would say that's it. No need to get discouraged and leave. You're going to fail. Okay. Have a good day. And that's how you do it. Piece of cake. Let's do one more just so y'all can go home and feel bad. All right, try this one. A ski gondola carries skiers to the top of a mountain. I always thought it was called a ski lift, but evidently that's not sophisticated enough, so you got to call it a gondola. Ski gondola carries skiers to the top of a mountain. It bears a plaque stating that the maximum capacity is 15 people or 35 pounds. That capacity will be exceeded if 15 people have weights with a mean greater than 169 pounds. Assume that the passengers are normally distributed, ding, 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 with a mean of 183 and a standard deviation. Now, what do you do there? Draw a what? Do not get cluttered up with all this junk. Find the mean and standard deviation. Draw a picture. So our mean and standard deviation, normally distributed, with a mean of this and a standard deviation of this. Now somebody tell me, the way that A is worded, is that 6.3 or 6.5? .3, good. Because it says greater than. So go ahead and do your 6.3 stuff.
So, the first thing we're going to do is draw a picture because we don't want to get confused with all that writing. Alright, so 183 is 184. 184 plus 42, so 184 would be 225, and 42 would be 66. And 184 minus 42 be, I have no earthly idea. Thank you. And 142 minus 42 is, I'll get that one, 100. All right, and they want to know 169. So you take your handy dandy marker and you mark, let's see, 142, 140 to 180, half of 140 to 180 is 20, 20 would be 160 right in there. And they say 169, so we'll say 169 is right there. And they want to know greater. 169, so we got to get a z-score for what? 169, is it going to be positive z-score or negative z-score? Negative, because it's on the left side. Okay? So 169 minus, I have no earthly idea, 183.7 over 42.1. 170 minus 183.7 is negative 13.7. So is that negative 14.7? Somebody check me. Over 42, or 15 over 42. And I'm trying to see if anything will go in there. 3 go into this 14 times on it, so that's 5 over 14, which is 5 over 15. I'd say it's around 0.33. What is it? You know it's around negative 0.3 something. Now, what if your battery goes dead and you do this by hand? And I'll give you an A for effort, and I'll count it right if you do it right. That's the way I feel. I'd rather you be able to do it by hand than anything. But 0.35 is your actual answer. And 0.35 is, so we're going to go 0.35 to 9999 on your calculator. And somebody give me that percentage, or give me 4 decimal places. Common sense. Does that check out? Well, what is this? 50%, and ours is past 50%, so 64% does make sense. So we type 0.6368, and then we get ready for B and quitting. 0.6368. And here's B. Find the probability that 15, blah, 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 have a weight, mean rate, greater than 169 pounds. You don't need to read the rest of it unless you just are interested in it. Because the rest of it, all it's going to do is what? It's going to confuse you. So just, because this right here is 6.5 terminology. Just find the probability that 15 blah, 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 blah is greater than 169. That is what we just did in the last 2 problems. We didn't have anything added onto it. So don't make it difficult.
sub 169 is equal to 169 minus 183.7 over 42.1 divided by the square root of 15. And I think we said this was going to be negative 14.7 over 42.1 divided by, well, the square root of 15 is 3 point what? 3.9? Somebody check me, what is it? Okay? Because the square root of 16 is 4. So, negative 14.7 divided by 42 over 4. I'd say it's around negative 1.47. Wait a minute, hold on. 42 divided by 4 is going to be more than 10. So 1.38 or 1.37 or something like that. What does it come out to be? 3.5. So, somebody take your handy dandy calculator. Now it says what? Greater than. So that's going to be negative 1.35, comma, 9999. And somebody tell me what that is, 4 digits. I'm sorry, what? 91%. Now a lot of you are saying, golly, how come it went up? You tell me. Because this must be in America, and Americans are what? Fat! In other words, if this was taken, anywhere else, it probably would not be 91%. I mean, you got people eating like 3 cheeseburgers at one sitting, yeah. It's going to go up. Okay? So let's check it. Y'all ever been to a McDonald's or a Wendy's and you seen what people buy their kids? I'm not talking about like a single meal. I'm talking about they're eating like 2 or 3 cheeseburgers. You ever seen people like that? And I'm like, that's abuse. That's child abuse. I mean, it is. They only need 1 hamburger. That's all they need. My son, Daddy, give me another. No. Starved to death. That's what I tell him. Eat a banana. I don't want no banana. I said, you ain't that hungry yet. Because dogs will eat turnip greens after 2 or 3 days. I say that to my kids all the time. What does that mean? When you're hungry enough, you'll eat anything. Our problem is, well, America's just got lots of problems right now. I love America. But, anyway. Does the gondola appear to have the correct weight limit? I don't know. What's the people's addresses? I don't know. Oh, I hate these questions. All right, let's read the question again. A ski gondola, it bears a plaque stating the maximum capacity is 15 people or, no. Why does it not have the correct, why does it need to be updated? Because 91% of those people are going to exceed the what? So this must have been done in the 60s. The plaque must have been done in the 60s. Because now everybody eats at McDonald's 3 times a day. And gives their kids 2 or 3 cheeseburgers. And we won't even talk about the Coca-Cola. So, I don't know. Does the Cantala appear to have, I would say no. There is a good chance that this thing will fall and these people will die. That's what I would say. It would be, let's see, there is a good chance that these people will die. No, there is a good chance that any individual passenger has a weight greater. Okay, that probably is it, but let's read the other one. No, there is a high probability that the gondola will be overloaded, so it appears that the number of allowed passengers should be reduced. Well, that could be a possible answer too.
Depending on where you can make it, like if you can change the gondola or not.
Yeah, I don't know if,
I think it's supposed to be B because it's talking about the weight limit. Not
Yeah.
changing it.
I don't think we're going to be changing anything, so I think this is probably your answer.
Usually.
Sorry. Thanks a lot, Miss Dyer.
I said D. You're the one that clicked
Oh, okay.
B.
Suppose there's a chance, so the gondola needs to be able to support more weight. Okay, they're saying, okay, that would, what's cheaper?
We're not getting a new one.
In other words, they're not getting a new one. Okay, that's it. Now, is it wrong? Is it wrong or is it less feasible? It's less feasible. It's not wrong. I would not mark it wrong if you pick B, but you got to think about common sense and you got to think about, are they, okay, weight limit C, we're going to go out and buy a new ski lift. I think the gondola is the thing that looks like a little bus that people fall off out of in Superman movies. Y'all know what I'm talking about? Or is it Superman movies or some of the movies where he's got to save them? Anyway. All right, now I want to go over a couple of things. So that basically covers 6.5. So, things I want to cover. I don't know. What time is it, Miss Dyer?
1:49.
Okay, what time's class over? Okay, we got plenty of time. All right. And this is not for just y'all, but end of semester, because this is when I start getting all these stupid questions. Okay? End of semester. We've got like 2 weeks left in the semester, and I'm going to go over a couple of things that I always go over at this time because people ask stupid questions. Most of them are in your test. Those stupid questions that y'all get points for, hopefully y'all have got them now. When is the final exam given? Well, it's given online, right? When? Usually I start the final exam if I don't already have it open, and some of them I do. Usually I start the final exam the last day of class, and it lasts till the last day of finals. Last day of finals. Now, I will make an exception here. I don't know about last day of finals. Usually I cut it off a day before, so that way I can get the grades done and get the grades in. I'll really teach you about grades. And you got to be in like midnight or 8 a.m. the next morning or whatever, and they're real bad about fussing at you. So I think I had it turned off at the right time. But in the summer, I usually just keep it open. This is the last semester I do it because one of my online students complained to my department head, and I can't keep doing that now because... Anyway. 2. The homework. Usually I've got it cutting off. Anybody know when it's cutting off? I think it's the last day of class.
I mean, it says online it's the 21st.
Okay, well, 21st. I guess I'll make it that. Cutting off on the 21st. Is that the last day of finals or the last day of class?
That's not the last day. No, the last day of class is like the
17th?
17th.
Okay. The last day of class is the 17th. Somebody tell me what day is that on?
Yeah,
Okay,
so
so y'all don't have class anyway, so.
Yeah, really, it's the 16th.
Hmm?
But really, it's the 16th.
Okay. Now, your grade
is kept up by what? Thermometer. Yeah. Okay. The grade book. So whatever the grade book has in it, I have to check the weights. I'm going to check that this week. Make sure all the weights are distributed right, the homework weight and all that good stuff. So you may see a little bit of a change. But you know what you're making. If you have 3 A's on 3 tests, and what do you got in class? You basically got an A. All right. Yes, the homework will help you out
You know that thing,
unless you don't do it and then it hurts you, huh?
how you said that in like the, something about dropping 2 in a unit or something, have you already done that?
No, it does it automatically. Grade book keeps up with your grade. That's for all these people that ask that stupid question, well, what's my final grade? Four. Unit 1 test. Unit 2A test. Unit 2B test. Is this unit 3 we're in, chapter 6? Unit 3, I'll probably call it A, which will be chapter 6. Do I have it as chapter 6? Do I have A and B on there? I do. So chapter 7 is what we'll get to. Chapter A, unit A, unit B, or unit 3B, that'll be chapter 7. All of those, you add them up, and you multiply them by 0.6. Add them up, divide them by 5, and multiply by 0.6. Because these are how much percent of your test, of your grade? Oh God, there's a 60, 20, 20 again. 20% is homework. And 20% is what?
Do you all of 6, chapter 6 homework, or do you skip any of the homework?
Okay, one thing that I want to, I don't know who asked that, but I'm going to cover that right now. Hubert's #1 rule. Well, besides, I treat students the way I want to be treated. I do not test what I don't cover. Okay? So I love the question even after I say that. Well, 6.4, do I need to do 6.4 homework? Only if you what?
Not only.
Okay, I've already taken it off. But I'll have 1 on there, and I'll get 15 emails, and they'll say, "Oh my gosh, I didn't see 5.4 on the homework. Do we need to do it?" If I didn't put it on the test, and I didn't cover it, then you don't need to what? Simple as that. How do you know if I covered it or not? You watch the dadgum what? Videos, or you come to class. Simple as that. Okay, so I do not test what I do not cover. I will take off any homework or test that I haven't what? That I haven't covered. Well, what about chapter 8? Have I covered it? Do you need to do it? It's called rocket science. Let's talk about the unit test. What does Course Compass or MyLab Plus, what does it do? It takes the what? Highest grade. Therefore, what does it do with your lowest grade? Therefore, it drops, or it does not calculate your lowest two. So, let's go through a scenario. We have to do this. Unit 1 test. Why do I have to do this, people? You figure it out. I make a 90 on the first attempt. I make a 72 on the second attempt. And I make a 95 on the third attempt. The computer, the grade book, when it does its grade, after you've turned in everything, it will not calculate these two grades. It will calculate the 95 because it is the highest grade. This is the next, I have to do this because this is the next question I have. Well, Hubert, what if I make a 95 on the first attempt? All right, why are you even asking this question?
If I make a 95 on the first attempt, do I need to take it a second or a third time?
Do I respond to that? No. Well, what's the computer going to do? What do y'all think it's going to do? What is my lab's going to do in this case? You make a 95 on the first attempt. Common sense would dictate that you're not going to take it the second or the third time, so it's going to put in what? And what will it do? It's going to calculate the what? I have to go through this example. I'll let y'all figure it out. Now, for the final exam, let's talk about that because y'all are going to ask some stupid questions about it. And when I say y'all, I don't mean this class, I mean all 120s. I usually give you 2 attempts. Why do I give you 2 attempts? Because the lightning that hits your house and the 6 dead grandmothers and 5 flat tires and all that stuff that happens to y'all when y'all take a test. Usually I have 33, 40, or 50 questions. Usually I do not do 50. Usually I do these 2. You have 2 hours for each attempt. Now, if you make a 52 on the first final exam, and you make a 94 on the second final exam, second attempt, what will the computer do? It will drop, it will not calculate this one. It will calculate the 94. All right, can y'all think of any other? Okay, let me reiterate something here because I want to get this again. We probably will not make it to 8 or 10. Okay? So you as students don't worry about it. Y'all laugh, but I have people that go hammy on me the last 2 weeks of every semester and think that I'm going to test y'all on stuff that I haven't covered. Okay? If I don't cover it, I don't what? I don't test. Okay? Now, I want to ask y'all a question. This is off the record.